How do you find the Norton equivalent circuit? Find out right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems. Homework problems to help you understand how to do them. Electrical engineering at your service.
Alright, for this problem we want to find the Norton equivalent circuit of this circuit right here. And what you see here is we have a current source, voltage source, and another current source. Semi sort of kind of parallel looking thing, but not quite because we've got a resistor in the way here. A resistor in parallel with this voltage source and another resistor in line with this voltage source, another resistor parallel to this. We want to find the Norton equivalent circuit with respect to AB. And we're going to use some source transformations to work this out. Now what appears pretty obvious is this source transformation right here between this current source and this resistor right here. But what we also have is a voltage source parallel to a resistor, and when you have that, what it says is that this resistor really isn't going to have anything to do with this because the voltage is going to be the same. It's not going to affect this output voltage or the current. So that resistor has to go. So let's go to, that's the first thing we're going to do about finding the Norton equivalent, is getting rid of stuff that isn't going to help us find this. We're going to continue. We're going to modify this circuit until we figure out what the Norton equivalent circuit is, and that's the final goal. It doesn't mean deleting the whole circuit. I mean, the circuit is what it is. So let's go to the next piece here. Here's the next piece here. As you can see, we've eliminated this resistor. The next step is what? What are we going to do here? I think the only thing we really can do is take this voltage source and convert it into a current source. We have a resistor here, and if we do that, we can get this thing out of the way and turn this into a whole parallel circuit. So this calculation is going to be figuring out what this current source is. I sub s is going to be equal to V sub s over R, and in this case your V sub s is 50 volts divided by 20 k ohms. Alright, and that comes out to 2.5 milliamps. Alright, so let's show this. We have this 2.5 milliamp current source, and it's going to be in parallel with the 20 k ohm resistance source. That's our next slide. And here is the source transformation right here. Now, what we have is all of these devices in parallel, right? So we have three current sources in parallel, two resistors basically in parallel. We can actually move these things around, and now what you have is it looks like this. Here are the three current sources. We just add those up, and two resistors in parallel. Now, one thing I'm going to show during this source transformation is that when you look at these directions, remember the current flow is from positive to negative. Remember that current flow is from positive to negative. And what this says is here's a positive terminal right here. Current flow is going to go this direction from positive to negative. But also, you might think that this is backwards. This actually is going from positive to negative, which says that this is the positive terminal. So it's actually going from positive to negative. Alright, so it's going from the positive terminal to the negative terminal, and if it's going this direction, it's going from positive to negative terminal. Alright, so this is how we tell the difference. This if it were to convert to a voltage source, would be flipped upside down. It's the same thing with this one. This one is the positive and this one is the negative. So let's go have a look one more time. What we've done is positive to negative. And here now we have this source going downward and this source going upwards. This is the positive and negative. This is positive, negative. This is positive and this is negative. Alright, now getting these all these sources, we're going to add these up, so your total so the total currents, the Norton current is going to be I1 plus I2 plus I3, which is just going to be minus 4 milliamps plus 2.5 milliamps minus 3.5 milliamps, and that gives us a total of 5 milliamps. I think I'm going back to doing this on paper. Okay, so and then the other one, R1 and R2, are just two parallel resistors. Is the Norton resistance, Norton resistance is going to be 1 over 20K plus 1 over 80K. And that comes out to 16K ohms. Alright, so and then in order to get our whole circuit, this is all going to combine into a single power supply. And which direction will this be? It's going to be downward because the net is going to be a negative minus 5 milliamps. And this is going to be all one resistor here, and we get our Norton equivalent circuit, and here it is. So here's our 5 milliamps, and I think 5 milliamps right here, and here's our 16K ohm. That's what is seen from terminals from nodes AB. Right, that concludes. Let's see. That concludes this. This program.
Thanks for watching my program. If you like my videos, be sure to subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.